Okay, so today we're going to talk about quadratic models, which is just a fancy way of saying quadratic word problems. And so before we start that, I want to preface with this. Word problems are just what we've been doing with a specific context, okay? So all we need to do is take each word problem step by step. But for this video specifically, we are not going to actually be given the word problem. We're going to be given the graph. We're going to talk about how to read a graph. Okay? So, how to read a quadratic graph. Okay? What is the shape of a quadratic function? We've done that at this point. It is this U shape, which is called a parabola. And so when put on a graph, right, if it's like this, when put on a graph or like this, it has a very specific context dependent on what my x value is and what my y value is, what context they have, like what label are they. Excuse me. So the first thing we're going to do is identify what the independent and the dependent variables are, right? So usually our independent variable is x, right? Usually it's x and this is y. However, we will not always be using the letters x and y. Sometimes we might have v of t, where v of t is my y and t is my x, right? So we have to realize that x and y will not always be the variables that we're using, but it does still stand that we have an independent variable and a dependent variable, and those will always be on the correct axes, right? Whatever is our quote unquote x or our independent variable will be on our x-axis, and our y-axis is our dependent variable. So it's important to note that every single quadratic function has a quote unquote x and y. The x and y will not always be the letters used, but the axes are still the same, okay? So you have to ask yourself what is dependent on what. And this right here, this note right here is really more so when we are given the problem than when we're given the graph. When we're given the graph, it's pretty easy, right? You can just say, like, for example, here, we can say, well, x is time and y is height of the ball. It's pretty easy because you just look at the axes. But when we're given a word problem, it might not be as obvious as when we're given the graph. And so independent variable x is often replaced for time, but not always. So there's other contexts, but a lot of times it's time. Okay, so this is the key, like, to how we're going to succeed here. Okay, these three things right here are critical. Okay, the y-intercept is the starting point. So when x equals 0. So what that means is that has to be in a specific context, right? So for example, if this is me throwing a ball or kicking a ball, my y-intercept is 0. That means if this is time and this is height, that means at 0 seconds before I even started, we were at no height. The ball was on the ground, right? So we need to be able to read what is happening. So the y-intercept tells me what my starting point is when no time started, right? Before the actual event took place, whether it's throwing a ball or making money, making a profit, whatever it might be. The y-intercept tells me where are we before we even start. So the starting point. The vertex. The vertex is the maximum or the minimum point, right? It is a minimum if it's concave up, minimum, and it is a maximum if it's concave down. Now, what's important here is that the minimum or the maximum value, right, the min or max value is the y value of the vertex. okay? So at x equals whatever, the function, so h, right, h and k, at x equals h, whatever h is, the function reaches its maximum or minimum of k. So we'll talk about what that means when we do examples. It's really hard to talk about it in theory. Let's talk about it in practicality when we get to our examples. And lastly, our roots or our x-intercepts tell you what the value is when y equals 0, right? So this changes meaning depending on the context. So let's go back to that whole I kicked the ball in the air, right? It started at 0. It reaches its maximum at this point, right? It goes up and then it goes back down, right? So let's say this was at 2 seconds. It reaches its maximum of 10 feet. Okay, so you see that at 2 seconds, my vertex is 210. At x equals 2, so 2 seconds. Oh, let me put feet here. At 2 seconds, it reaches its maximum of 10 feet. And the question is, when did it hit the ground again? At 4 seconds, let's say. So we're going to go through a bunch of examples of how to read specific graphs. So let's start with this one. So we have time in seconds and the height of the ball. So Tommy, whoever Tommy is, Tommy right here, is throwing this ball up in the air and then it's coming back down. Okay, so this is the path of the ball. This is how high it is going and how long it is going. So as time goes on, the ball goes up and then it comes back down. This is the equation of the graph. Now, I can say, yeah, it looks about right because it's concave down, right? So that negative tells me that it's concave down. And this 5 tells me it's my y-intercept at 5. So that's also really important here that the function matches the graph. But we're going to trust that the function matches the graph for right now. And we're going to figure out all these different questions. At what height was the ball thrown? Was the thrown at? Do you like my English? Was the ball, at what height was the ball thrown? I'll say that. I think that's English. Okay, at what height was the ball thrown? So this is asking, where was the ball before I threw it? Or before Tommy threw it? So this is my y-intercept. And what was my y-intercept? It's here. You can use your context clues. This is going by 4 to 20. So this is going to be 5. Or I can say, because I'm given the function, I know it's going to be 5. So I could say at 5 feet. So I know because my y-intercept here is 0, 5. Okay, next. What is the maximum height of the ball? So again, maximum height. Which variable is height? Is x height or is y height? Well, x is going to be height. I'm sorry, y is going to be height, right? Here's height, and this is on my y-axis, right? This is my x-axis, x is time. So it's asking, what is the maximum height? Notice it's not asking what is the maximum time. It is maximum height. That brings us back up here, how the minimum and the maximum value is our y value. So it's asking, what is my minimum height of the ball, my maximum height of the ball? So I have to go to my vertex and figure out what is the maximum. Now, we don't know exactly what this is, and for just time's sake, because I'm not going to go through the whole thing, if you were given this problem, you would have to find the vertex of this function if it's not clear on the graph. But for right now, we're just going to estimate. And my estimation, so this is 65, so this is going to be 70 right here. So I'm going to say about 68. Okay, so I'm going to say 68, approximately 68 feet. Right? Is it in feet? Do we know? It doesn't tell us. Height of the ball. We're just going to put feet. So again, it's really important. The maximum height is not the vertex. You find it from the vertex because this is the y value of the vertex, right? So our vertex here is what? 2, right? 268. Again, that's an estimation. So from my vertex, I find the max height. So it's 68 feet. How long did it take the ball to reach its maximum? So how long? Is that looking for an x value or a y value? It is looking for an x value because how long is time, and here is time. So it says, how long did it take for the ball to reach its maximum? So again, we're talking about the maximum, but we're not asking what is the maximum. It's saying, how long did it take for the ball to get to 68 feet? And we know that from the x value of, so let me write x here, right? We know from how long. So I know it's going to be 2 seconds. So from my vertex, I find the max height and how long it took to get there. So here, this 2 is here. And this is how we got it. Again, it's asking you a specific question, like how long or what height. So you have to ask yourself, okay, is this X or Y that they're asking for? Now, next, is the ball always going up? This is a pretty logical question, right? You can ask yourself, is the ball always going to be going up? Well, no. Why? What do we have that makes the ball eventually go down? Gravity. So the ball is eventually going to start going down. It's going to reach its peak, its maximum right here. And then eventually it's going to start dropping. So no, the answer is no. It only goes up from what second to what second? From 0 seconds to 2 seconds, right? It reaches its maximum here and then it starts dropping. So for this section of the graph only, is it increasing? So it only goes up from 0 to 2 seconds. When did the ball hit the ground? Now, again, the question is when? So is it asking, it doesn't want an X or a Y value. It wants an X value. So when did the ball, because it's asking for time. When did the ball hit the ground? So this is asking, at what time was h equal to 0? When the height was 0. The ground is, height is 0, right? It's as low as you can get without going underneath the ground. So when did the ball hit the ground? Well, we look at our, this is asking for our x-intercepts. Now, our x-intercept on this side is not really important because it's going to go into our negatives. And we can't have negative time. And that's really important, that you cannot have negative time. So therefore, negatives are not important when we're talking about time. Okay? So h equals 0. What's my x-intercept? So I'm going to only look at this x-intercept, and it is going to be at 4. So the ball hits the ground after 4 seconds. Okay, let's try another one. So it asks, so this is a graph that my X is number of tutoring packages sold, and my Y is how much profit I'm making. Okay? And this is the function. It is concave down because A is negative, right? Now, let's look at this here. How many packages would have to be sold for them to make maximum profit? How many packages? Is that X or Y? Number of tutoring packages sold. Profit. So this is going to be X. But again, it's talking about maximum profit. So I'm looking at my vertex. Again, we are going to estimate for the sake of estimating. So my vertex is going to be, oh geez, about, let's guess here. My vertex is, you know what? I have a better idea. Negative 0.7x squared and plus 140x is, you guys can't see it, but I'm putting it into Desmos. And the vertex is 107,000. So that means that this graph is not accurate to the actual function. So we're going to use what the actual vertex is here. So let's say, so the vertex is 107,000. Actually, it does make sense because here's, yeah. So 107,000. So my X is 100, my Y is 7,000. So how many packages would have to be sold for them to make maximum profit? So again, we know we're going to talk about the vertex because it says maximum here. But which value of the vertex? It's the X. So I know it's going to be 100 packages sold. 100 packages. Now, what is the maximum profit that can be made? So it's asking for profit. What is the actual maximum profit? And profit is my Y value. So my maximum profit is going to be $7,000. And how many packages would have to be sold for them to make no profit? Now, again, when our x-intercepts go into our negatives, they are not important as far as our context here. However, if we look here, my x-intercept here is 0, and then I have an x-intercept here, which, let me check what it is, which is 200. So what that means is how many packages would I have to sell for me to make no profit? So 0 profit. Again, no profit. This means y equals 0. So therefore, it is my x-intercepts. I would have to sell 0 packages or 200 packages. For me to make no profit. Let's try another one. At what height was the ball thrown at? That is not English, Miss Masood. At what height was the ball thrown? Okay, at what height was the ball thrown? So we got to look at, again, this is asking before anything started. At what height was it thrown? Meaning before time began. So t equals 0. So I'm looking for my y-intercept. So it is going to be at, looks like it was kicked from the ground. So at t equals 0, at 0 feet. At what height? 0 feet. Oh, meters. It's given in meters. Okay, next. What is the maximum height of the ball? So what is the maximum height? So is that X or Y? Y. So is this what point are we dealing with here? Well, we're dealing with the vertex, but we're dealing with the Y value of the vertex. And so my vertex is given, thank God, and here it is 15.51 meters. That is the maximum height. Keep in mind, the reason it's the maximum height is because it's never going to go further. It's going to reach its peak, then go back down. It is not the maximum time because look, 1.75 seconds is not the maximum time because right here we reach 3 seconds and that's bigger. Maximum means it can't go any higher. The Y value is the only thing that cannot go any higher. This will never be touched. Okay. How long did it take for the ball to reach its maximum? Good question. How long? So we're dealing with time, but we're still talking about our maximum. So we're still talking about our vertex, but we're talking about the time it took to get to the maximum. So 1.75 seconds. Is the ball going up? Is the ball always going up? No. It is only going up between 0 and what? 1.75 seconds, right? This, at this point, is when it starts decreasing. Here's increasing, right? Here it's increasing, but then it starts decreasing. So between 0 and 1.75 seconds. When did the ball hit the ground? So when is h equal to 0? That is here. See how h is equal to 0? And that is at 3.53 seconds. Last one. Yep, last one. How much would the seller have to sell? So this one here, my X is selling price and profit, right? X is selling price, S, and profit, P. So how much would the seller have to sell this item for in order to make maximum profit? So how much would the seller have to sell it for? How much? Now, this one's a little bit harder because both of these are in money, right? It's a selling price and a profit price. Both of them are dollars. So how much would the seller have to sell? So you have to really look at the context. How much would the seller have to sell this item for? Selling price. To make maximum profit. If it asked, what is the maximum profit this seller can make? Then you're dealing with Y. But this is saying, how much would I have to sell this item for? And that is 35 whatever dollars, let's say. $35 because this is X. What selling price would this item have to be in order for the item to make no profit at all? So again, what selling price? So we're still dealing with X. Would this item have to be in order to make zero profit? So look, again, zero profit means P equals 0. We have two values in our positive X value range. If this went into the negatives, if this looked like this, it would be different. But we have two values. So it would be either $10 or $60 would make no profit.